Okay, let's do this question. Let me write the question. The function such that f is given to be from R to R is defined as follows, where f of x is equal to 3x squared if x is element of a rational number and negative 5x squared if x is not a rational number. So which of the following is true? Okay, they are just asking is true, so only one choice is going to be the required choice. So f is continuous at all x element of R. Oh, it's not continuous, it's discontinuous. F is discontinuous. Okay, f is discontinuous and f is continuous at only at x is equal to 0 and differentiable at x is equal to 0. So it's f is continuous only at x is equal to 0 and differentiable at x is equal to 0. F is continuous at x is equal to a and non-differentiable at all x element of R. D, f is continuous at all x element of rational number and non-differentiable for all x element of R. So EF is continuous at all x not element of Q and non-differentiable at all x element of R. So we are expected only to get the true one. Okay, now you can look at the question and work it out, and when we come back let's learn how to get the right choice locked in. Okay, now let us check. This is the first check if f is continuous or not. Okay, so we need to make this check. So this is the requirement. If f is continuous at x is equal to 0, then as x tends to 0, f of, I would say, limit x tending to x0 of f of x should be equal to f of 0. Okay, in both the cases. Both the cases means, I mean, for rational and irrational numbers. So we will have to verify that. We will have to find that out. So let's do that. Now first we need to make the check for x element of Q. So for x element of rational number, limit x tending to 0 of f of x is equal to limit x tending to 0 of f of x. For this case is 3x squared. 3x squared, which when we apply the limits will give us 0. Now for x not an element of Q, that means it's an irrational number. So limit x tending to 0 of f of x is going to be equal to limit x tending to 0 of, in this case f of x is negative 5x squared. Okay, so you can rewrite this as negative 5 limit x tending to 0 of x squared. You apply the limits, you still get 0. So from 1 and 2 we conclude that limit x tending to 0 of f of x is equal to f of 0. So this means f is continuous at x is equal to 0. Okay, so this is ruled out. Okay, this cannot be, and we have to find if it is continuous at x is equal to a. Okay, so let's check this. Check if f of x is continuous at x is equal to a. Is it not? X is equal to a means okay, that means it is not, it is a non-zero value. At x is equal to a means x is not equal to 0. So as limit x tends to a, this is for every x element of rational number, f of x is going to be equal to limit x tending to a of 3x squared, which is nothing but 3a squared. Now for every x not element of q, okay, this is going to be limit x tending to a of f of x is equal to limit x tending to a of negative 5x squared is equal to negative 5a squared. Okay, now clearly if you were to see, the functional values produced in both the cases are not agreeable. They do not agree. Right? You are able to watch that? So how do we conclude? This is how we conclude. Limit x tending to a for every x element of q of f of x is not equal to limit x tending to a for every x not element of q of f of x. Okay? So this means f is not continuous at x not equal to 0 or at x is equal to a. So that means if we go back, this is ruled out. C is ruled out. Okay. So and we have to look into this D and E. Now proceeding on, if we were to look at D and E, it talks about continuity and also about non-differentiability, right? So we have to check if the function is differentiable or not. So let's go and work that out. So differentiability, I'm going to check differentiability at x is equal to 0 first. Okay, so if a function is differentiable at x is equal to 0, then it means f dash of 0 should be defined as limit h tending to 0 of f of h negative f of 0 divided by h. Okay, we will work with this definition. So now for x element of rational number, f of x is equal to 3 times x squared. So that means f of h is 3 times h squared. That means f dash of 0 is equal to limit h tending to 0 of f of h negative f of 0 divided by h. This is going to give me limit h tending to 0. F of h is 3h squared over h. This has got no value. It's f of 0. H gets cancelled, giving me limit h tending to 0 of 3h. You apply limits. So what do you get? You get 0. Now for x not an element of rational number, f of x is equal to negative 5x squared. So f of h is equal to negative 5h squared. So therefore f dash of 0 is limit h tending to 0 of f of h negative f of 0 divided by h. This is limit h tending to 0 of 5 negative 5 h squared over h. H gets cancelled, you get limit h tending to 0 of negative 5h. You apply the limits, you get 0. So clearly, what do you see there? Both of them are agreeing, right? You have a 0 and a 0. So f dash of 0 is one and the same. Okay, there isn't any change at all. So I'm going to state that since f gives the same, or f dash gives the same value for rational and irrational x element. Okay, just say x for because it's considered rational irrational x. Okay, this means the derivative x's at x is equal to 0. So only at x is equal to 0 the derivative is existing. Now we cannot check the derivative for x not equal to 0. Why? Because there is no continuity for the function. So we don't have to do that. So we can stop right here and go back and check the choices. See, so differentiability, non-differentiability is actually a big no. So this one is off, this one is off. The only thing that is remaining here is the function is continuous at x is equal to 0 and differentiable. So this means B is the only choice. The function is continuous at x is equal to 0 and differentiable at x is equal to 0. Okay, so that concludes. Please like, share and subscribe. Thank you.